Sanjit, take it away. We're good.
All right, so I'm representing Team Aristobuol, and a talk I'm going to be giving about is the project I've been doing for NASA's Space User Interface Technology Challenge for Students, or NASA Suits, as I think Kent briefly mentioned. So in this talk, I'm going to be talking about the design for head-mounted display systems for lunar missions. So a little bit of information about this project is, by 2024, NASA hopes to really advance human autonomy through technologies for elevated demands of surface exploration and extreme terrestrial environments. So basically, NASA wants to send more astronauts to the moon by the year 2024. They want to really expand lunar exploration. And their long-term goal is they want to eventually, I'm sure we all know about mission to Mars. So basically, NASA wants to master more about challenge the lunar exploration. And one of the things they want to really test out is user interface systems through head-mounted display. And that's where augmented reality comes in, because the goal is to really help assist crew members doing tasks when it comes to space exploration. And some of this involves navigation, geology sampling, extravehicular tasks, and more. So all this stuff is done when going on lunar exploration. And the long-term goal is they want to use this exact same concept and procedures to augmented reality that they apply for lunar exploration, eventually all for mission to Mars, using this exact same technology and concept. So this is a little bit about ourselves. This is the whole team. I'm the project lead and software engineer for this project. Dr. Mridul Anjaneya here, he's the faculty supervisor in my project, along with assistant professor of computer science at Rutgers University. So we're all from different backgrounds, combining our skills together to really build the next advancing technologies to advance space exploration. So I'm going to give you a little brief background about the project and the research and development behind it. So one of the things that I briefly mentioned is extravehicular activity. So it's basically activity done by an astronaut outside a spacecraft. So some of these activities can involve like working on satellite systems or repairs, could be exploration. There's a lot of different things about extravehicular activities. In fact, a lot of spacewalkers have to use an extensive number of tools to be able to do EVA, and especially for stuff like geology sampling and navigation. So one of the main core components, especially in EVA, any operations in space, is being able to monitor the astronauts' vitals. So in space, there's no oxygen there, of course, so that's the whole point of spacesuits. But one of the things is, during EVA, there's a lack of oxygen, atmospheric pressure, intense radiation, and the gravity confronts on the human in space. So there's a lot of things when it comes to vitals that's very important to monitor for the astronaut in real time. So basically, one of the experimental tools that NASA really hopes to experiment with is augmented reality through HoloLens 2 device. They want some heads-up displays that can really help the astronaut to do tasks and monitor vitals in real time. All right, so the main challenge is, the question we have to ask is, how do we help astronauts on lunar exploration? So as mentioned, the challenge, of course, the goal is to develop heads-up display software that's like UI displays to help the astronaut explore the surface on the moon and hopefully other planetary bodies as well, such as Mars. So that's the main challenge, and we want to develop it. So basically, the whole goal is the head-mount display system. It must be able to help the astronauts in terms of telemetry streaming during EVA operations, collecting samples, navigation, and it must be able to help guide and protect the astronauts from hazards during EVA environments, because it's a very stressful environment. It must be flexible enough for the astronaut to collect geological samples and operate with a variety of tools through the displays. And furthermore, it must be very simple and efficient use for the astronaut. That it's simple, it's like one click. That's it. Simple, very simple use for them. So as mentioned, long-term goal in this challenge is NASA wants to eventually send more astronauts on Artemis mission to the moon by 2024, like literally expand mission on the moon. So these are the core objectives and components. So navigation, EVA system state, geology sampling, auxiliary conditions. So all these four actually connect because navigation also involves from EVA when it comes to doing EVA tasks or excavation sites, like going from one point to another to another. So, the spacesuit is there to help the astronauts, provide oxygen and, all their vitals, but spacesuit also has a limited number of time. So, it's important for the astronaut to be able to do everything simultaneously as they're doing their activities. So through augmented reality, as they're navigating on the moon, navigating waypoints or collecting geology samples, it's very important that at the same time, there's a way through the headset display that it also has the astronaut be able to keep track of their vitals at the same time to do their activities, because, if you're doing their activities and your vitals, of course, go out of range, it's going to be a big, big problem for the astronaut. So in a way, it's going to help the astronaut be able to do everything more easily, safely, efficiently, and hopefully by the time they're home from space, they'll be in good conditions. So there's a lot of really, really big challenges in doing stuff in space. It's very dangerous, especially, due to lack of oxygen and spacesuits limit. So navigation is definitely going to rely on EVA, and then geology sampling also relies on navigation EVA because, of course, as you navigate, you're going to have track of vitals and, of course, be able to know where you're navigating. And the thing about geology sampling is what kind of samples astronauts will collect on the moon, whether it's rocks or soils, etc. And then auxiliary conditions. That's basically more rather lighting conditions in control method. So control method would be the user interface through gesture clicks or voice commands. Lighting condition is basically, since it's dark in space, how to provide extra lighting effects for the astronaut to be able to see what they're collecting, what they're doing. All right. See, is this right? Okay, perfect. All right. So this is the solution here now. So through Microsoft HoloLens 2 device, as mentioned, astronauts will be able to have a better idea of how to navigate from one waypoint to another, have a better way to keep track of lists, like a checklist of what kind of geology samples they're to collect or what tasks they're to do. And of course, we also have a component that gives them more information about general geology samples they're to collect in space. And of course, astronauts themselves are also scientists and engineers. They do have a STEM background, so they have ideas. And the goal, of course, through augmented reality will be able to make sure everything is kept in check for them. They're able to do everything efficiently, and of course, at the same time, keep track of their vitals. And that's the whole point of telemetry streaming. So telemetry streaming is basically involves monitoring not just the condition of the astronaut's health, but also the condition of the spacesuit, because spacesuits do tend to get damaged in space during tasks, depending on what the astronaut's doing. So it's very important that, the spacesuit's also in good condition, because the spacesuit's condition goes bad, the astronaut's condition can also go bad. So look at it like this: the spacesuit is the main power system, and heads-up display system is very, very, very critical, essential component for it. So one of the other unique features that we're implementing is biometrics warning. So like, let's say when you're monitoring astronauts' telemetry for, like, let's say heart rate, or could be the temperature of the spacesuit, if things go out of range, there will be a visual display of a biometric warning that'll say either heart rate out of range or suit condition warning. We do provide those biometric warnings here. And then, of course, as mentioned, geology sampling is going to be another core component tool, and not just knowing what to collect, but knowing where to navigate to collect these tools. So that's where wayfinding algorithms come in handy. And overall, with the use of our old UI system, astronauts will have a variety of options of which features to use and navigate through to be able to help them on their mission to space. So these are basically the images. As mentioned, you can kind of see some of the stuff we've actually done. So if you look at the top left here, this is actually a UI display feature that allows the astronaut to toggle through different features and collect samples of what they're to explore. So this is actually a geology sampling feature over here that gives them a little information about the sample they're to collect. Underneath the top left, this is a note-taking feature. So astronauts, as they were to collect different geology samples or explore, or like as they navigate through the moon, if they're exploring certain things about the moon or seeing certain things, they found certain things on the moon that other people may not know of, They can also record what they're absorbing and doing. So that's the whole purpose of note-taking feature. And then of course, right here, all the way to the bottom right, this is the whole biometric warnings. If you see here, it says suit condition warning. So as I mentioned before, if the condition of suit, let's say like the temperature, for example, that was to go out of range, basically this biometric warning signal will pop up alerting the astronaut you're about to go out of range. So that will hopefully, have the astronaut realize right away and how to take action to be able to, get back to like the ship in good health. It's basically, look at it like this. It's the whole point of biometric warning signal is to alert the astronaut. And I really feel with this feature, it can help the astronaut's life be saved because, in space, it's very, very important due to lack of oxygen. And, if the suit condition goes wrong, it's going to be very, very harmful for the astronaut. And to the top right, this is how our actual display feature looks. So I did modify it a lot more, which I'll show in next slide, a simple demo of how I use the product. So in this demo here, this is actually, you're going to see me testing out the HoloLens 2 app as if I was the astronaut. So I'll skip a little bit. So onto the top left here, that's the whole task list feature. So two ways you can actually use the components is either through gesture click, like what I'm doing, and another way is voice command. So this is actually a little bit information about certain geology sampling tasks that astronaut would do and collect in space. So this is if they want to reference a certain techniques and tasks of geological samples they were to collect in space. That's the whole point of this documentation you're seeing here. So underneath, you can see some general information about the samples. So as you see, instead of clicking for vitals through the telemetry button, I actually just use voice command. All right. Yeah. So see, through voice command, you're basically able to project the same features as you do from gesture clicks. In case the astronaut doesn't really feel like using an arm or their arms are too sore for gesture click, they can also use voice command, as you saw here. So I'm using Jarvis. It's basically this is what my telemetry will look like. As you see here, I was pretending as I was the astronaut and I'm able to take notes of what I'm collecting on outer space. The little problem is it is a little bit hard to type with the HoloLens keyboard. Oh, was that the whole video? Oh, sorry about that. I think it stopped for a sec. Okay, perfect. Yep, so basically I'm able to record, take notes of what I was to collect and then save it. And then basically if I want to move that note-taking feature out of the way to do other stuff, I can just literally drag it or just based off of gesture clicks. Or I could just maybe make the size a little smaller. So that's what I'm doing in the video. So then another feature I'm using is also mapping navigation. So that's for wayfinding. So as you see, there's a small waypoint I already set up here. Basically, the goal is to try to calculate two of the trajectory waypoints. But this would be location A, and then there would be location B. That's actually still a feature I'm actually finishing up. But this is basically what the simple demo would be if there were if there was a way I can plan out multiple waypoints and then be able to have it like calculate how far I am from distance A to B to C to etc. I don't know why I did that. So this is actually the checklist feature that I'm able to use to keep track of notes I was to collect. Oh, I'm sorry, not notes I was to collect. Keep track of tasks I was to do. All right, so now I'm going to talk more about the need for the project, like what's like the short term. So I guess the need is first, really finishing up the telemetry streaming data for vitals in real time and getting it to parse more accurately into UI display. So for this, NASA actually already provides us the data in a JSON file that you would have to parse and integrate into Unity 3D that can communicate and read all that vitals they provided us with the data along with what the range should be for each and every vital. Polishing up the navigation component, getting the waypoints out, calculate depending on where to compute the pathfinding and where you're trying to plan out the trajectory. So finishing up waypoint navigation / wayfinding component, that's another essential component we would hope to finish up. Improving the UI designs would be also great. Finish up the EVA system tool through HoloLens, and then I guess have lighting effects and also photo capture and have a recording feature to work with HoloLens, because one of the things we also want to do is astronauts should also be able to take pictures of what they were to collect if they were on the moon. They should also have pictures of those or be able to have a recording feature where they can live stream from HoloLens back to ground station of like all the tasks they're doing. So people from ground station can also provide any additional feedback or support. Ground station as in people from Earth. So the want is something we want for long term. So one of the things, of course, we would love to integrate is a computer vision API for object recognition that can, do like recognizing what geological samples astronaut was to collect if they were on the moon. So it would like automatically recognize saying, okay, and label it as, okay, this is a rock sample, this is a soil sample, etc. So one of the ways we would do that using Microsoft Azure Vision API. So basically through that, we'd be able to get computer vision working through Unity 3D, which is a game engine we were using. We would also like to, as mentioned, improve and have waypoint navigation fully working, like have it really, really nice working. Another thing that we'd love to integrate is a holoportation feature, which was done through Microsoft Research. So holoportation is basically demonstrating real-time 3D construction of an entire space, including people and object, using a set of new depth sensing cameras. This was actually, let's put it like this, it's basically like Star Wars, you can say, or Star Trek. It's like there's like a set of depth sensing cameras around with a person wearing HoloLens. It reconstructs their whole 3D environment. And basically those people would holographically communicate, interact with each other. So that'd be a really, really unique feature to try out in space, from like an astronaut doing holoportation with a person from ground station back on Earth. And then an artificial intelligence chatbot for guidance. So the AI bot would basically be something like, you can say, a Jarvis, that like you see in Iron Man. It would basically be a smart AI that could kind of help the astronaut out in terms of accurately guiding them or keeping track of their telemetry. So basically the goal is to make it like an Iron Man Jarvis. So one of the potential features my team and I hope to look into for this is machine learning. And now out to acknowledgement. So I would like to first thank the NASA Suits team for selecting my team and I for the competition. Dr. Jing Huang, who's professor at Mercer County Community College and also has been my leadership coach, coaching me in terms of being a good leader. Dr. Midul Anjaneya for agreeing to supervise this NASA Suits project, since one of the requirements was to have a faculty advisor. Array of Stars, which is a startup in Toronto. Actually, they were the ones who provided my team and I a HoloLens 2 device. Otherwise, HoloLens 2 is a very, very expensive headset, and NASA did require us to write a proposal to secure HoloLens to develop with. But Array of Stars really saved us time, and they were also good in terms of feedback and collaboration with my team and I. So huge applaud to them. Kelly Mann, he was actually my NASA mentor, and he's also engineer on the Jarvis team, for his additional feedback on features that'd be useful in outer space. And then to Professor Matthew Stone, who's head of the computer science department at Rutgers, for writing up the letter of acknowledgement to the NASA Suits people in getting my team and I selected. Overall, these were my references I used in terms of integrating research into my project. This will be a survey feedback, which I think I sent out to Kent. If not, I can send it out again. And I hope you enjoyed this presentation. Thank you.
Thanks, Sanjit. We had a couple questions in the chat. I know I'm going to start. Hey, Matt W., do you want to unmute yourself and ask your questions?
Yeah, sure. Hi all. Yeah, I wanted to ask how progressed the project is, because I also asked who provides funding, but you already mentioned, Sanjay, that it's a grant, so it's some sort of competition. Do I understand it correctly that NASA is going to push the technology and create a competition and a grant for developers?
Yes, so actually the grant, we actually saved time on that the minute Array of Stars from Toronto sponsored my team and I, so we didn't have to worry about the grant. We just got to the technical, thank goodness.
Right. So how far are you with the prototype? Like what you showed us, is this a working prototype or just a video presentation and kind of like this is what we are going to have?
It is working, but the telemetry streaming still needs more work, I would say. Navigation is at a very, very basic use. I would like to improve it more. I guess I wanted something like, I don't know if you played Call of Duty or GTA before.
Yeah.
But like, in GTA, if you were trying to get to one location, you can kind of like press the pause button, you have a radar map, and you can select which location you want to get to, and it'll draw like a line of one location to another. Kind of wanted something like that.
I see.
So like, I do want to integrate like some gaming UI features, just because, it just might make more sense. That would be something definitely useful for the navigation. That's something that still needs a lot more, I would say, work and more maturity. And telemetry streaming, like I said, that is a main component for everything. So like getting the integration working for that, that's very critical. So I would say in terms of advancement, it's still getting there. We hope to have more stuff, hopefully by end of the year.
Okay.
Does that answer your question?
Yeah, more or less. I've got one more. Before I see other people have got questions, I want to take still the time. Would you mind to share some technical information how you're creating it? Like, is this a sort of a platform to build AR applications?
Yes.
Are you coding from scratch?
Okay, so partly we're code. So the AR stuff, there's libraries out there. The rest of the other features that we code from scratch. That's just like coding anything else in Unity. So Unity is the essential game engine.
Unity. Okay.
Yes, Unity 3D. For HoloLens, we are using a very special library that's called Mixed Reality Toolkit, MRTK. It's a library you use for developing for HoloLens, and it's developed by Microsoft too, of course. You know, Microsoft, they provide it all.
Yeah, here's our device, now learn our language.
Basically, so MRTK is what we're using for all the UI features and the integration and basically jump starting the project. But you have to use MRTK for HoloLens. That's like, it's Microsoft. So yeah. So that's what we are using. And then for the telemetry, that's JSON, which we are integrating to Unity. So there's, again, libraries out there for that as well. But it's purely more or less Unity 3D.
Okay. I see. Thank you. And how far, I mean, like, do you have a scope and a set deadline, or are you basically running until your funding runs out?
So we do have deadlines. By end of the summer, I would definitely like more mature telemetry streaming. I would definitely like the whole navigation component. And then I'm definitely going to be continuing the NASA Suits competition again around September. So over the summer, I'm actually looking for a couple of students who are like college students who are, you know, looking for like work opportunities, want to gain experience, and really would love to do something for NASA, because this technology for augmented reality, it has potential impact and can change the whole way space industry does stuff.
Yeah, absolutely. And I think I missed, like, because you brought closer education and experience of your colleagues, but I think I missed your background.
So yes. So I'm an undergrad student myself at Rutgers University. I'm a computer science major. My background's, of course, in a lot of gaming simulations, VR, AR, game development, and I'm also building my recent background in robotics and learning machine learning on the side as well. You know, go on a crazy adventure with tech.
Sure. All right. Thank you. Thanks a lot. Good luck, and I will try to follow you.
Sure. Thank you.
Thanks, Matt. Hey, John Collins, do you want to unmute yourself and share your question? All right. You can see John. Are you in there, John, still? Anyway, it seems counterintuitive to rely on HL technology when you potentially have a whole visor to work as a display, and gesture recognition would be complicated significantly due to the suit gloves, whereas sensors and switches could be incorporated into the suit as peripherals. What were the considerations when selecting an approach for the solution?
All right, so in terms of the consideration, NASA actually takes care of most of the hardware components when it comes to the suits. So the whole telemetry and gesture recognitions, they already have that system designed to communicate with gesture clicks to the HoloLens. But actually, the thing is, NASA is not going to be having their astronauts wear the HoloLens with sending them to space. They're just going to integrate the whole UI display onto their own heads up display system on the helmet of the spacesuit, actually. So basically look at it like this. It's like what you see in Iron Man. There's no headset that an astronaut's going to wear. It's basically the heads up display UI is already going to be on the helmet of the spacesuit. And then they already have like sensors and systems built onto the suit that are compatible for gesture recognitions and telemetry streaming for vitals. So all that stuff is already built to the suit. It just has to communicate to the UI of the helmet.
Thank you. Yes. Okay. So Justin, do you want to?
I'd be happy to. I was wondering what's the next steps for the team and for the competition in general? What kind of timeline are you looking at, and when does NASA decide which competitors win?
Okay, so that's a great question. So by end of the summer, what I'm seeing my deadline, hopefully by end of summer, is have the telemetry streaming more mature and fully working, having the whole navigation display working, I guess, and having all the core components put together. In terms of like who's gonna win, so there isn't exactly like a winner. It's more like a research competition. I guess you can say the teams they selected back in September 2020 for the competition were the ones that were the winners. Only the top 20 teams got selected. My team was one of them. But after you've been selected, basically their goal is to mentor you into publishing a research paper on this. So I guess once the whole basic components are put together by end of the summer, starting September, next step will be, of course, working on like a chatbot that could be like a Jarvis in terms of guidance and like being able to, like, you can say, be like a smart bot and helping the astronaut in tasks, or being able to give them guidance on what to do if their telemetry is going out of range. So I guess one of the really big components for next step would be machine learning system, like developing a machine learning model through the display. So that's where, something like actually like the real Jarvis would be useful.
Okay, and Chase, did you want to unmute and ask your questions?
Hello. So you mentioned that you had access to the HoloLens 2, which comes with eye tracking features. Now, I did show up late, so I didn't see any utilization in like the last half of the demo showing the eye tracking features. Is that something that you have plans for integration, or?
That's built in.
Yes, but you didn't utilize it.
Yeah, we're not utilizing the eye tracking at the moment.
Okay, is that a future enhancement you plan to do?
So we haven't really thought about the eye tracking too much. We might, but we're not sure how that'd be useful in terms of space, unless you have any suggestions for it.
Well, imagine for an instance that you are doing a repair on the rover there in your simulation. You've got the tools in your hands. As mentioned before, the spacesuits are big, they're bulky, they're hard to move in. Not sure if you've ever worn one, but it's kind of like trying to do a repair underwater. And so when you've got something like that going on, your hands and gestures aren't going to be able to input it. Now, as you mentioned, Jarvis is going to be somewhat helpful, but it is amazing what sort of UI enhancements you can do with UI if you put the time into it. For instance, you had those menus there in the center of the screen taking up much of your field of focus.
Right.
Those were off to the side, and then you glanced over at one for a couple seconds, and then it moved to the center so that you could work on it. It would greatly enhance the ability to work under those conditions.
Right. So actually we are actually trying to fix the problem with some of the menus, the way it's kind of like a little set up.
Mhm.
Yeah, so I guess we might use eye tracking for that.
Okay, that's basically what I want to ask.
Great, thank you. These are good questions. I think Kent has one last question over there.
Yeah, I'm oversimplifying, but the way that I see this kind of huge project, I mean, you have a lot of design elements, and then you're going to develop and engineer it in the HoloLens 2, which is still kind of early. But then it's one thing to be just designing and developing for the HoloLens, another thing to do it for space. So I guess I'm just wondering, what are the unique, I know you talked about lighting briefly, but could you talk about the unique challenges that doing this for space and using the suit present for the project?
Sure. So in terms of space, that's one of the things, NASA is still also experimenting with themselves as well. So the thing about space and how it would be implemented in terms of using space is, that the UI displays do have to be centered at a certain range. So like, it should be easy for the astronaut to glance in, and, it shouldn't be able to like kind of burn their eyes out too much. But like another thing is also, as mentioned, as much as we're deploying on the HoloLens, NASA already has like the solution figured out and how to, display all that features through their own helmet display. So I guess like in terms of testing in space, they do have something called human in the loop testing.
So with that in mind, it's almost because they have their own proprietary heads-up display with probably a really good field of view that most of us don't have. I mean, it's almost like you're kind of making it sound like really all the challenges are design focused as opposed to anything else.
It's purely design.
Cool. Interesting.
I see Susan, you have a question? Susan, Oldham, do you want to unmute and ask your question or your comment? I can read it. It seems that you could use eye tracking along with image recognition to identify parts and interfaces and augmented information, much like the Army tank operators do.
Yes, so actually image recognition, a lot of that would come to the computer vision. So that's where the computer vision API would be used through recognizing images and objects like through labels and being able to accurately label them. So that's where we'd be using most of the image recognition for.
Cool. And Matt, looks like you have another good question here. There he is. Got him unmute, Matt.
Okay, I thought that you were gonna read the question. So I'm asking if you convert your project or have been converted into a startup, basically commercial project, what skills would you look to hire? What skill set you would look to buy from the market to get this project moving faster or advanced in advanced way?
Oh, for skills, I would probably want more than just AR people focused. I'd probably want also people from robotics and like, you know, aerospace background, but skills I want to hire. I mean, if you're talking for augmented reality, definitely people who have experience in UI UX design. So people who are very good designers can design great UI features, something that's more sci-fi and futuristic. Definitely want people who have Unity experience and along with any integrative tool like JSON files or APIs or experience with MRTK, and also people with experience in developing machine learning models. So people who have skills in developing like machine learning agents or smart chatbots. That's definitely another skill I'd like people to have. Unity experience, I definitely would want most majority of people to have. That's like another great skill. But I guess outside of Unity, I probably want people to also have skills in hardware focus as well, because the way I see UI display is not just used in spacesuits, but I also would like to see it be integrated with other hardware systems that can be integrated into spacesuits like EMGs and exoskeletons. So people. Okay,
so if you had funding to hire only 3 people, what would that be?
Probably people from AR and Unity.
Okay.
And robotics.
Robotics. Okay. Thank you.
I hope you get funding, abundant funding, then you can hire and build this all the way your dreams are seen. Okay, so that was pretty much our lineup of questions. And Sanjit, do you want to can you put in the chat your contact information again? I know it was on your slide, but I know there's people out there, and we are recording this.
Should I just put my LinkedIn on here if that works?
Yeah, that's fine. And we will be posting this on our YouTube channel. Kent, you look like you have something to say. You have that look on your face over there.
I was just going to say, I know you had, Sanjit, I know you had that kind of questionnaire or form at the very end. We had just posted this event in the Facebook group. So maybe we'll just share that link, that form, and then Sanjit, if you want to do your LinkedIn and that in the comments there as well, in case anybody wants to follow up, because I know this chat is not forever.
Sure, that's fine.
May I ask one more question? It's a rather general question, because this is the first time I'm attending this meeting, and I see that this has been created, right? And you are kind of a guest, Sanjay, to bring closer your project. So what this group is about? If someone could quickly bring me up to speed.
So
go ahead, Sanjit.
Oh yeah. So sorry, can you repeat the last part of your question?
Yeah, like what this group is about, right? Because I see people being interested in VR in general, and you are presenting your VR project. So I just wonder how it all fits in a scope of this meetup. Like, are you meeting every week, every month? What that group is trying to achieve?
This is my first time presenting here.
Yeah.
So
you're referring to the larger group that's hosting Sanjit as the presentation. Is that what you're referring to?
Yes.
Yeah. So the Seattle VR meetup group is kind of who's managing this, and it's a part of the SETA. So it's the Seattle Immersive Technologies Association. we have not been as active over the last year, but a majority of what we do is host people like Sanjit in person for presentations, but we have been doing more webinars lately. We used to host like demo nights and like social nights and things like that in Seattle. I would say the main ways to kind of be a part of it, and I'm not sure if you're in Seattle or calling in remotely, but our Facebook group, the Seattle AR VR on Facebook is super, super active. We also have a Discord channel, which we're kind of continuing to ramp up. So yeah, I mean, really, we're here for kind of like every element of like the XR space, whether it's community and just like the social side and getting people connected, to education, and then just like experiences and letting people try different things. So let me know if that answered your question.
Yeah, much clearer.
We're still trying to rediscover our cadence coming out of COVID, so it's been a weird year.
Oh yeah, definitely. More than a year.
If you have projects or things that you'd like to present, or you think the group would like to know, just get in touch with us.
Okay.
Yeah. Okay.
Fantastic.
Thank you. I know we really appreciate you, Sanjit, coming in from New Jersey, and we have a couple other ideas and people who are interested in presenting. So we might wait until August, but if any of you have any ideas or suggestions or want to be part of our humble team here in Seattle, you don't have to be in Seattle, but we'd welcome you as if you want to help out in any way. And I think that's it. I'm going to do a shameless plug, as Kent suggested, as I'm now working as a recruiter for the XR and gaming industry. So if you are looking, or you're for a job in that field, or if you're hiring in a job at that field, you can reach me at, here, I'll put that in the chat, but I'm always happy to talk to anybody about hiring or getting jobs or whatever, but the XR field and game field is our focus. Yes, fingers crossed for Q4. Amen there, Kent. All right, anybody else? Last call. I'm going to turn it off, stop the recording very formally.
Yeah, thanks everybody for attending, and thanks again, Sanjit, and thanks Cami and Justin for helping make this a reality.
Yeah, okay.
Yeah, thank you so much.
Everybody.
Yeah, thank you,
Thanks for
Sanjit.
speaking.
See you later. Bye-bye.
Bye.
Have a good day.
Thank you, Sanjit.